system security, or we call it as ICS systems. Uh, so what are the various security measures and what are the risks that is involved within this? So those are the topics that we'll be discussing it here. So I just would like to say what are the major agenda that will be covered during this particular course. So we have to understand what are the basic fundamentals of industrial control systems. So which I try to cover it today. Along with that, what are the various threats and the vulnerabilities which is possible in ICS, and what are the various security principles that we can take care of. And there are various standards, frameworks, and the risk management categories. So there are four important factors which is related to risk management, especially in such type of systems. And then followed by, we'll be discussing about detection response and the resilience and the emerging trends. So these are the basic topics which will be covered during this course. So today I'll try to cover the few topics that is related to this. Yeah. So the first thing, which is about, first let us understand what is ICS. So the industrial control systems, they are mainly designed, they are mainly system that is designed which helps to monitor and control the industrial processes. So it can be like manufacturing system, or it can be a power generation based, like energy based systems, and the water treatment as well as the transportations. So it can be anything. It is not apart from only this domains. So there are various domains where we actually need a continuous 24 by 7 monitoring and to control the industrial processes in all those areas where we can have the ICS or the industrial control systems. So there are various types within this. We have four important, we can define it into four categories. The first one, which is SCADA, and the second one is DCS, third one PLC, and the fourth one, which is HMIs. The SCADA is nothing but which is a supervisory control and data acquisition type of ICS, which is one of the oldest, and it is a very efficient method, we can say. And the second one, which is used in various industrial plants, that we call it as a distributed control systems. And the third one, which is like the programmable logic controller, that is also used in various industries where we have multiple field devices which can be used for automating the complete process. And the last one, which is the human machine interaction. So nowadays we know that there are many devices, small devices, or there are various sensor devices which is present in every agriculture domain, or if you consider any health domain, healthcare domain, or any kind of industries, we need to have a user interface or the dashboard which will connect a human being or a user to such type of system or a kind of device, or it can be any machine as well. Okay. So these are the various categories of ICS. So hope you understood what is ICS. So that is nothing but it's a basic system which helps to monitor and control the complete industrial processes in various domains. So what are the major uses of ICS? So it is not restricted to any one or two domains. It is present in almost every area wherever we need to monitor and control the complete processes. So it can be a field of electrical. So wherever the power is which is getting generated via water or via wind or any other forms. So even water and wastewater segregations, all those things, all those areas still we can use ICS. Apart from that, we have oil and natural gas. It's also used in natural gas refineries, chemical industries, transportations, pharmaceuticals, pulp and paper, food and beverage, or any discrete manufacturing industries. It can be any automotive industries or aerospace or any kind of durable good factories. Okay. So these are the various areas where we can have ICS. So first, let us understand how the entire working or the basic architecture of this system operates. So we have mainly three important factors, that is the sensors, controller, and the actuators. So the sensors are just like your input devices. It tries to acquire the inputs via various field devices from various industries or the refineries or the plants, how we are going to read the input. Okay, so it could be the input device where we can retrieve or acquire or collect the inputs over here. And these inputs will be given to the controllers. So where the major logic or the complete process that has been defined within this element. And based on this processes, it will ask the actuator to do the correct action. Okay, say for example, if it is monitoring the room and once the room temperature goes beyond a particular threshold, then the controller will give the instruction to the actuator to do the action, like please give alarm to the user that it has crossed the threshold. Okay, so it can be any kind of actions that can be initiated by the actuators. So these are the three important elements within this ICS operation system. One is a sensor, second one is, so this is mainly for collecting the inputs. And this is the complete logic, the processing logic, which is written over here. And based on this, the instruction will be given to the actuators, which will perform the action, the required action at the right time. Okay, and we have the HMI, that is a human machine, that's a kind of dashboard or the user interface, which will be integrated with the controller logic. And so that will help to give certain actuators. So if you see, we have a set of controlled processes where we are collecting certain inputs and it can give other outputs. So this control processes, why we need to have this while we are receiving the input and then sending the output via the system is, there may be a certain set of disturbances. These disturbances may be sometimes what happens is there may be a fluctuations in raw materials or due to some environmental changes, or there may be a sudden shift in demand also. So these are the certain disturbances which may affect this thing. So that things has to be controlled, uh, entire process, that is while acquiring the input till how the process that is happening within the system and how it produces the output to the user interface. Okay. And here, the complete thing, that is the controller logic, which will be along with the sensors and the actuators, it is in turn will be monitored. There will be a remote diagnostics and maintenance. That is a remote terminal units could be there. If you see the SCADA systems, there will be a separate control center would be there where we will have the central server and remotely, which can be maintained using the remote terminal units, RTUs are there or PLCs can be used. So these are very, very important for a diagnostics at any that is at the real time, and then to take a necessary action or some maintenance activities which need to be taken care. So this is overall about the industrial control system operations. So first, let us discuss about the most important category, and it is we can say it's one of the oldest method. Still, it is used in various gas pipelines or some oil refineries in many more industries, which is still it is in use. So basically, this SCADA system it is designed to collect field information. It can be about the pipe strength, what is the pressure, the temperature, any kind of parameters which we can say it according to the industrial type. So, which helps to collect the field information and this field data, which will be sent it to the central computer facility. So, there will be a control room or a central server room, we will have it. So, all this inputs, the field data will be sent it to the computers and which will those informations can be viewed by any operator, the data operator who is there within that particular server room. So that will be displayed either in a graphical form or in a textual form according to the requirement. So it will allow any operator, the data operator who is within that particular room facility. So he will be able to monitor and control the entire system from a particular location. That may be a central location. At the real time, he can manage the entire stuffs. So here in the SCADA systems, if you see, we need many hardware as well. It is not only the software system. It's a combination of hardware as well as the software system. So we have different hardwares like a server, control server is required, which has to be placed in the central room or the computer room facility. Along with that, we need to have certain communication equipments. It can be a telephone cable, telephone line, or a normal cable, depends, fiber cable, whatever it is there, or via satellite or radio waves, etc. Along with that, we need to remotely monitor that. So we have various sites. There will be different field sites would be there. So it may be geographically distributed field sites where we need to have a remote terminal units, or we can have both PLCs, programmable logic controller units, or the RTU units, which can actually control the actuators, what should be the action that should be performed, as well as to monitor the sensors, how the sensors are working, what is the strength, and how the input that has been passed to the controller, everything that can be managed via such hardware systems. So if you see the layout of this SCADA systems, we have the main center, that is a control center room, okay, where we have multiple machines. Okay, so this is our user, the dashboard, which actually it will displays the necessary informations over here so that the operator can observe the value either in the textual or the graphical form in order to take the necessary action. So there will be various engineering workstations, and this all will be connected via LAN. That is, we have a data server where the data which will be received from the field, which will be stored over here, and we have the logic unit, that is a control server over here. So that is our SCADA MTU unit. And there will be multiple routers which will be connecting to the outside world, right? So it will be how this will be connected. It can be in any one of the form, either using the satellite connection or radio or connection, or any kind of wide area network, which we can say it. So this will be connected via this medium to the various field sites. So geographically, different places, the different centers are available. So this all can be linked together and which can be monitored by the person or the operators who is sitting at the control center via this set of units. Okay, so in every field site, we can have a either the PLC, programmable logic controller, or we have some terminal unit, remote terminal units where we can see the readings, everything. And this all can be connected to your control center. So this is the general layout for any kind of SCADA systems. So just to understand like how this can be monitored, so I have just taken a simple case study. So how this will work and what type of vulnerabilities, or say for example the security things that can be managed within this type of system. So let us consider, for example, the gas pipelines. That is very, very important part, especially let me consider about the Indian economy. Gas pipelines is one of the essential part. So we have found there are multiple malware and the ransomware viruses which are targeting such type of SCADA networks. So it is not only in this industry, in various industries, we'll have various types of vulnerabilities and a range of threat. It varies from system to system. So, the gas, say for example, it is like a Hindustan Petroleum gas or the Bharat Petroleum gas refineries. So they need to monitor this process, what type of attacks that is possible, and how we can diagnose it at the earlier state and we can prevent it. Okay. So for that, how this SCADA system can help. So there are the staff may, what happens is when you have such type of attacks, the staff may lose what is the access that is coming to the HMI. So they were not able to get the real time data, what is happening at the field site, and to taking the necessary actions which may not be taken at the right time. So that may be the disadvantages or the limitations, because we are not getting the right data, and that is to be stored in your data servers or the data historians and the polling servers. So because of that, what happens, sometimes false alarm or the false indications would be given. So which is in turn, it is going to affect the efficiency of the your production system, or it may be it finally leads to the economic loss to any of the country, right? So this is, suppose if this is a problem statement, if we consider in such type of SCADA systems, then what type of security mechanisms that can be done, or how we can prevent that and then reduce such type of threats. Okay. So this is a case study. So what is the limitation of just having, without having the security measures within your ICS, that is the industrial control systems. So if you see the current SCADA systems, okay, the problems are that we don't have any automated mitigation policies. Okay, suppose if you have identified there is some risk, okay, but what is the mitigation policy that has been defined for that particular risk, which is not defined as such now. And there may be cases that will be issues related to the sensor, isn't it? The fault that can be detected. And it is not that efficient or much reliable. So it is very less reliable, because what happens is there will be a frequent updation that is happening with respect to the units of the measure that they read it for every parameters. So it may be overloaded, and what happens is it may drop the communication task. So what we need to have is that we need to have such a secured system within this ICS, and that can avoid such type of false alarms or any kind of attacks that entering into such type of system. So we need to have an automated alarm management system based on the real-time values. So we can propose a solution, say, for example, if it is a gas pipeline, so whatever the data, that is the length, the width, and the temperature, pressure, all the other parameters that has been uh, defined in the sensor devices or any remote devices. From that, we are trying to read the data, and data will be analyzed, forecasted, and we are just checking for that. So the live data, the real-time data, which will be forecasted to check is there any anomalies that is present, okay, any kind of attack or the security threat that is defined in this particular upcoming data. So if it is there, then we can do the proactive alarms, and based on that we can generate the report and do the this thing. So what happens is that, so we need to design alarm management and analytics systems. So when you have the fault classification, what happens is, along with the sensor input and whatever the data that is coming in the packet form, when you're transferring the data from one place to another, so we are getting the packet data. So this two types of data which will be considered, and we are applying some machine learning or deep learning techniques, try to classify the fault classification or the right classification as per the input data. And if there is any false positive detector, then we can just add it within your analytics systems. So only based on the pure data, that is removing the anomalies, whatever the actual data, based on that we can create the alarm, or subsequently the reports and the analysis report which can be generated. So this is one way of providing the solution if such type of attacks are happening in SCADA systems. Okay, so just to understand that how we can propose a solution for this is like, there can be a AI system which will predict what is the occurrence of alarm based on the process sequence. What happens is that, and based on that, it can classify what category of those alarm is, and we can generate a proactive alert if required, and then we can create a reports of all that. And those reports can be sent it to two of the places, that is to the maintenance department as well as to the process engineering. And if there is really any activity to be taken by the maintenance department, then such report will be sent to them, and they will take the necessary action of repairing and rescaling of such instruments. Otherwise, it can be say, given it to the process engineering, so they can reset the process access limit, maybe the threshold verifications, or due to some environmental factors, if there is continuous false alarm that is happening generated, then we need to reset the values, isn't it? So that can be defined by the process engineering section. And yeah, similar way. So we try to group the alarms that is based on every equipment, and that can be those type of information is also provided to the controller. That is, they will taken care of such revising the control strategies also in order to eliminate such kind of false alarms. Okay, so many times it happens because of the wrong input, the false alarm will be generated, which will actually affect the growth or the production of the particular industry. Okay, so then we can suggest a type of solution like this. Because of this, we can have various benefits. Okay, so the sensor data can be analyzed and we can do the identification of such type of alarm pattern, and whatever the false positive or the false negative alarms, which can be classified using some classifier models where we can apply traditional or the advanced machine learning algorithms, which will help you when you detect any this thing failures in any kind of devices, then at the earlier stage when we can do a timely maintenance, as well as we can reduce the cost of the maintenance as well. And apart from that, we can say that we can reduce the impact of change, and there will be a continuous monitoring and recognizing the alarm patterns, which will helps to generate the reports for the future reference. So this is about the SCADA systems, how this can be applied via the security features. And the second important system, which is about the distributed control systems. So it is like it may be in the same geographical locations, but which is located within a specific uh, what do you say, specific area, but there are multiple sites that has been present. Within that, if you need to control such type of operations, then that can be carried out with the help of this distributed control system. So this has been used in various industries like oil refineries or wastewater treatment or some power generation systems, as well as in chemical manufacturing, automotive, and pharmaceutical. In various domains, this has been used. So here, the DCS, it's just like a control architecture. We have a supervisor who will be controlling the entire set of elements. We will have a multiple, what do you say, integrated modules, sub-modules or the subsystems which will be there, and they are responsible for controlling the entire localized process which is located within a specific geographical area. So this will have localized controllers that will share the overall task of carrying out how the entire production process that has been defined. So this can be defined by a supervisory controller, and he can monitor and take the necessary action as and when it is required. So if you see the DCS implementation, so we have the like via internet or wide area network, which can be connected to the outside world. But this is like, let us consider we have this supervisory level. So this layer, if you see, this is your supervisory level, and this is the field site. Okay. So in this field sites, we have machine controller, where we have modem HMI systems are there, and some motors are there. Okay, so here we can also have, it can be managed with the help of the programmable logic controllers, where we have AC drive and the DC servo motors. So I just want to say what are AC and what is the use of this AC and the DC servo motors. So here we have AC drives, and here we have the DC drives. AC servers are more efficient and it can provide a smooth performance because it offers a better speed control. Along with that, it can give a reduced noise with a lower weight. Okay, so the weight is very less. So we can say it is weightless, and it can reduce the noise that is created in the industry. But what is the usage of this DC motor is that here it is helps to deliver the strong torque, but the problem or the limitation with respect to this is very bulky and it is less efficient compared to the AC motors. Okay, so this all can be used as a part of your. We have it within the part of program logic controller, and so this is like remotely to access it. By the supervisor level, controller level, we need to have some RTUs again, remote terminal units are provided, and this all can be connected via the routers or the HMIs to your via the local area network. As we are saying, it is within a specified area, maybe it is located in the same geographical locations. So here we have the supervisory level is basically the data, whatever that has been gathered from the field sites, which will be stored in your data center or the data server. And we will have the HMIs, that is to read the values and monitor the progress of the system. And here we have the control of the multiple servers, the integrated servers, and we have various engineering workstations to it. And through this, we can monitor the complete process, and there will be a manufacturing execution units, and there will be a manufacturing information systems as well as the ERP system, which will help you to automate the complete process of such industries. And the third one, which is about the programmable logic controller. So this is the one which is a part of your SCADA systems as well as in the DCS system, that is a distributed control systems. So this will act as a control component in your entire architecture. So it can manage locally about whatever the processes that is happening. And within that PLC, we'll have a feedback system so that it can give the input which will help you in the further diagnosis. So here we also implemented a primary controller in a smaller control system configuration, which will discrete processes, maybe like a power plant, blower controls, etc. Or we can have a
Hello, ma'am.
automobile. Hello.
Hello, ma'am.
Yeah, can you hear me?
Yes, ma'am. Please, yes, I can hear you, ma'am. You please, if you disconnect, you will join back in 10 minutes. I think we are still using the free Zoom server service.
No, no, I couldn't understand. What did you say?
Hello, ma'am.
Yeah.
I think it
Could you
gives
please
us 10
repeat?
minutes break, so we'll join
Okay.
back, please. If if it disconnects, we'll join back using the same link, ma'am.
Sure, sure, sure. Yeah, I'll do
Yeah,
that.
if it disconnects, join using the same link.
Okay, fine, sure.
Thank you.
Okay, so right now, should I?
Continue, continue, ma'am.
Okay.
Continue, continue.
Yeah, yeah. Within this system, we have a programmable memory also so that you can store all the instructions which are necessary to which are necessary, along with some logic controllers and the timing, the scheduling details, the communication, or any kind of arithmetic operations, or if you want to read various type of operations to read, write data files, etc. All these operations which can be stored using memory, that is a user programmable memory, which is a part of the PLCs, that also we do have it. So which helps in your further analysis process. So if you see the architecture, how it works, so I have shown this, actually it is a pulse. So we can see that is in the field side. We can use PLCs to define it in detail over here. so which is connected via the LAN, that is the local area network, and we have all the data to be stored in a servers. And for monitoring, we have a engineering workstations at the control center. And so this is like the PLCs, which is located at your field sites where you want to monitor the industrial processes. So we have multiple modems over here, and that will be connected to the human machine interfaces, which is a user dashboards. And we have a variable frequency drive, so which helps to manage. Okay. And apart from that, we have various sensor devices. Proximity sensors is just to understand the devices. So we have proximity sensors over here. Also DC servo motor and the AC drive. So these are the various elements that is defined within the PLCs over here. So as I told you before, AC drives that is more efficient for a smooth performance, and it also gives you a better speed control. But when I compare it with this DC servo drive, so this is better for, or it can deliver a strong torque, but it is much more bulky compared to AC servo motors. So we can say since it is bulky, it may be not that efficient. So it is less efficient compared to it. So this is the basic set of elements that is defined within this PLC unit. Okay. Now, so I just covered the basic fundamentals, that is with respect to what is ICS and what are the various types of ICS. So we have discussed about SCADA systems, PLC, programmer logic controller, and the distributor control systems. So this all places where we will be having HMIs, that is part of your entire ICS system. Okay. Now, how we can provide a IT, and we have also discussed like if it is in a SCADA systems, like the existing SCADA systems, there were various chances of vulnerability or some kind of security threats. Then how that can be monitored and managed. So we can propose some solutions by using a say for example, if there are false alarm that is continuously getting generated, then you can define a model where it can classify the correct and the false alarms, and then it can prevent such type of damages or the loss in the productions which can be managed. So that is what we have discussed in the small case study. Now let us discuss about how do we compare the ICS and IT system security. So when I say ICS, that is Industrial Control System, it is like a physical systems, isn't it? Physically, various hardware, machines, servers, sensor devices, proximity sensors, and we have a variable frequency controller unit, remote control unit. So various physical systems that is available in the part of as a part of the ICS system. But when I talk about IT system, this is purely what do you say, data management, which is a pure information or the data based complete system. Okay. So here we have many characteristics and they are different from the traditional systems. So what are the various differences or how do we differentiate between the ICS characteristics from the traditional data management or the IT systems? So one is that when I talk about hardware, then it is very important that hardware devices, the risk is actually significantly high compared to the IT systems. So, and what happens is sometimes it is very much risky to the health as well as the safety of the human lives. And sometimes it can cause serious damage to the environment. And there will be a financial issues as well with respect to production losses, and there can be a negative impact which is created for any nation's economy. So ICS have different performance and the reliability requirements as more hardware elements or the embedded systems or the part of your ICS systems. So we should be very careful when you are defining the performance